Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.38. While solving this problem, we will be using Kirchoff's voltage law. According to this law, a cumulative supplied and dropped voltage across circuit elements in a closed loop is always zero. We also will be using Ohm's law. According to Ohm's law, voltage across any resistance R is the product of current through that resistance and the value of resistance. Now move towards the problem. Exercise problem number 2.38. Find Vx in given below figure. This is the circuit diagram of given problem. We have to find voltage Vx inside this circuit. This is a closed loop circuit, so we will use Kirchoff's voltage law to solve this problem. Before using Kirchoff's voltage law, first we have to nominate current inside the circuit and its direction. I am assuming the direction of current counterclockwise. You may take clockwise as well. Now make polarity notation across resistances according to the assumed direction of current. Current entering terminals will be taken with positive sign and current leaving terminals will be taken with negative sign. Polarity notation across this 4 kilo ohm resistance is already provided, so we will not assume its polarity. Now write Kirchoff's voltage law equation for this closed loop circuit. Start from here. Current entering terminal is positive, so 6 volt of this voltage source will be taken with positive sign. Move to next voltage source. Current entering terminal is positive, so 8 volt will be taken with positive sign. Move to next element. Current entering terminal is positive, so voltage across this 6 kilo ohm resistance, that is the product of current through it and the value of resistance, will be taken with positive sign. I multiply by 6k. Move to next element. Current entering terminal is negative, so 24 volt will be taken with minus sign. And move to last element. Current entering terminal is positive, so voltage across this 4 kilo ohm resistance, that is labeled as Vx, will be taken with positive sign. Now in order to solve this equation, first we have to make only single variable inside this equation. Right now it includes two variables, one is I and other one is Vx. So replace Vx with its value so that single variable left inside this equation. Vx is equal to the product of current through this 4 kilo ohm resistance and the value of resistance. Current that is passing through this resistance is I, so the value of Vx will be I multiplied by 4k. Now inside this equation only one variable is left, that is I, so we can solve this equation to calculate the value of current I. Add 8 and 6 together, it will become plus 14, and subtract plus 14 from minus 24. The result will be minus 10 because the larger value has minus sign along with it. And add these together, 6k multiply with I will become 6ki and 4k multiply by I will become 4ki. Their sum will be equal to 10ki. Now place minus 10 on the other hand side of equal, it will become plus 10. Divide on both sides with 10k to calculate the value of I, that will become 1 milliampere. We have calculated the value of current I. Now we can calculate voltage across this 4 kilo ohm resistance, that is labeled as Vx. We know that in order to calculate voltage across any resistance, we should have two parameters. One is the value of resistance itself and other one is current through it. In previous step, we have calculated the value of current, so we are able to calculate voltage across this 4 kilo ohm resistance. So the equation of voltage Vx will be Vx is equal to I multiplied by 4k. Here I is taken with positive sign because current is entering from positive terminal of this resistance. Replace I with its value, it will become 1 milliampere multiplied by 4k. Now multiply 1 milliampere with 4 kilo ohm. Milli will cancel out with k. The product of 1 and 4 will become 4 volt. So the value of Vx inside this network is 4 volt. This was exercise problem number 2.38. Thank you. See you again in next video.